Thank you, Alicia, for the kind introduction. The authorship of this paper is by co-chair Andy Brunner and Laurent Warnet. So between us, we look after the running of TC4. So what we wanted to do here, and given this is the last presentation of this TC4 mini symposium, we know we have the enthusiasts here. So thank you for staying. This is what I want to do. I want to give a brief introduction to TC4 and past achievements. I want to look at some of the complexities and challenges of the materials that we're currently working with, some of which we've seen already actually today, and finally make some conclusions and what's the outlook. So it's nice to link back to previous ECFs. So in fact, the origins of TC4 go back to ECF 5. That was in Leoben in 1984, and that's where it was decided that we should have a technical committee looking into the fracture of polymers and composites. Adhesives got added later. And it was set up initially by Gordon Williams and Henning Kausch. They agreed to be the original co-chairs of the committee. And it had its first meeting in 1985. So looking at 1984, so the committee is now 40 years old. And is, we like to think, still going strong. The first meeting. So Andre Pavan took over from Henning as co-chair in 1989, and Andrea and Gordon chaired up until September 2017, when Andy Brunner and I took over as co-chairs, together with Laurent as the secretary. And we were re-elected in 2020 and 2023. So what does TC4 do? Well, we achieve the aims of ESIS by doing the following. So we think we provide a welcoming community to researchers in the field. Hopefully that those of you who come along to TC4 meetings will agree with that statement. Those of you who haven't yet, then please do come along and put that statement to the test. What we do is we identify work areas where there's a requirement for fracture mechanics based methods, and we identify a topic leader. So we've heard all about round robins. We run round robin activities to refine the procedures and develop the standard. As John Allen was just telling us about. And we all try and avoid being lab F. Anyway, we meet twice a year to progress technical activities. Typically, the meetings are held in the spring and in the fall. And we've moved to a system whereby we have one online meeting, which is typically in the spring, and we meet together at a location, which typically is one of our participants in the fall. We run an international conference every 3 years. So we actually ran our last one in March of this year. Okay, so what about what we do? What are the different things we've been doing? So this flow chart gives an idea of what we've been doing in the area of polymers on the left, short fiber composites on the right. And we'll look at composites on the next slide. But certainly it started off with polymers, looking at sort of static KC/GC standards. And that was one of the first things that occupied the committee. That led to an ISO standard initially published in the year 2000. JC was started around about the same time. Its path to standardization has been more tortuous, as we'll see in some cases. Looking down the left-hand side, quasi-static methods led to dynamic methods, looking at increasing the rates to, say, 1 meter per second, which was also standardized, and beyond, going to sort of between 1 and 30 meters per second. Coming down the middle, you can see some of the other things. So obviously the J, there was a quasi-static J, an impact J. More recently, a load separation criteria activity running in parallel to that, to try and add more information about the suitability of materials to J testing. And moving down, you can see we've had protocols on measuring GC via a cutting technique. So that was a protocol written initially by Gordon Williams. We have a protocol, not standardized, but it's actually a method that will work relatively well for some quite complex materials. And down the right-hand side there, we have the essential worker fracture method, which has been standardized. So that's a plain stress method for films, very popular. Environmental stress cracking is ESC. That's currently underway, and we've got activities running in that area. Moving down, notching. So notching was something that was not terribly well defined in the early standards, and that ambiguity has sort of left certain problems within the system, which we feel needed to be resolved. So we've had an activity on notching, and quite a lot of progress has been made on that recently. Coming down to elastomers, so I'll say a little bit more about that in a moment. But certainly the extension of the left-hand side here to short fiber composites was something that was also achieved and was part of the early work. Moving on to composites and then structural adhesive joints. So clearly composites, and we've seen many examples of people using this. Obviously the static DCB method, the mode 1 method, the mixed mode static protocol was the fixed ratio mixed mode, which was used. And on the right-hand side, more recently, there we had the mode 2 method using the ELS method. Currently underway are activities to extend that to 1 meter per second. There's a fatigue DCB round robin running, which was alluded to by John Allen, and G2C at higher rates are things that certainly are on prospect. We have a peel activity. So peel is something that we originally looked at in terms of flexible laminates, but more recently it's being applied to delamination peel. Structural adhesives on the right there, you can see we've standardized mode 1, mode 2. We're looking to extend that to fatigue and high rate. So what are the complexities and the challenges that we face? So certainly manufacturing techniques have been coming on in leaps and bounds recently. So for example, 3D printing are becoming very popular in industry. Obviously, we're all familiar with the benefits of 3D printing, but of course, these lead to quite profound changes in microstructure, and what are the consequences of that for testing? So that's one thing that we need to think about. Also, what about when materials become very tough and equally ductile? For example, the addition of particles. So how do we deal with these highly toughened materials? And then what about very soft materials? So Alicia was talking earlier about hydrogels. Now these pose us with many, many problems. So this is clearly a complex and challenging area for the committee. How should their fracture properties be measured? And for example, what about exposure to complex environments? Again, for polymers, this is a big question. So let's just have a look at quickly 3 examples. So example number 1, which is an activity underway led by Francesca Boldi, University of Brescia. So one of the activity leaders of TC4. Some recent work about looking at, for example, cellular materials. So these are not too dissimilar to sort of 3D printed materials when you think about the variation in porosity. So you can have higher or lower porosities, but we're obviously interested in measuring fracture resistance. So how do we go about doing that? And what are the problems? Well, of course, the continuum assumptions that we rely upon are violated. The materials can be highly inhomogeneous. How do we prepare samples? How do we apply size? How do we notch the samples? What about the constraint? What's the state of stress? How do we analyze the data? Homogeneous, for example, with a ductile response. So this is one of the, these are some slides from a recent paper by Francesco, where he's been looking at doing that, really applying sort of known J techniques to these sort of materials and looking at the effect of resistance to fracture initiation using the J technique for these sort of materials as a function of the relative density of the material. But clearly many challenges are faced here and lots of work to be done. Moving to the second example, and apologies for those of you who were here before the break, so you would have seen this slide, but one of the areas that I've been leading is structural adhesives, and one of the challenges we're facing there is the materials becoming very tough and very ductile and being increasingly difficult to analyze and test within the constraints of LEFM. Obviously, we're using different methods to increase that toughness through for example, soluble rubber or nanoparticles or different toughening particles with different properties like core shell rubbers and things. And traditionally, this has led, for example, in particular, when we use mode 2 loading, to very large damage zones. So large fracture process zones being present with situations like micro cracking occurring. So we have particular issues also with nonlinearity and potentially the failure to reach a steady state in that sort of experiment. What are the sort of potential approaches here? Well, of course, we've done quite a lot of work using effective crack lengths and within the LEFM regime, and also the J approach using combined with imaging methods such as DIC and potentially the use of devices such as inclinometers to measure rotations. Then we've been making some progress in that, but of course there's an ongoing activity looking at this. Moving to the third example that I just want to briefly touch upon, and this is the area of soft materials. So a little bit similar to the aerogel work that Alicia was talking about. Obviously, if you've got rubbers, then these pose us with additional challenges. So I just introduce here the TC4 rubber team as they named themselves. We didn't name them the rubber team. So Sylvia, Claudia, and Bernd there head up the TC4 rubber activities. And there's a round robin taking place at the moment. So there's opportunities to get involved with that. So challenges and open questions here are manyfold. So rubbers, which are filled elastomers, are highly complex materials. So they are non-linear elastic, and they can have dissipation within their mechanical behavior. We can have interaction between the filler and the polymer chains, which can be reversibly lost. So quite a complicated situation. Obviously, they can harden due to chain orientation. They can show hysteresis with reversible bond breaking leading to heating. So LEFM is not applicable, and that's not the end of it. So the little schematic on the right shows the many of the deleterious things that can happen to rubber molecules. And all of these are, of course, of interest in terms of what are the effect on the mechanical properties. So what's happening within TC4 is obviously we're interested in the fracture resistance here. So what sort of specimens? So pure shear specimen is being employed. Single edge notch tension is also being investigated. So this is a big activity. There are quite a lot of participants in this round robin, and of course I'm sure Sylvia would welcome additional people because there'll be follow-on activities, new round robins in this area. So I was involved in this round robin also, and I was amazed that how important, for example, the material storage was, and the specimen preparation and the notching and the detection of crack initiation. So multiple problems here have to be ironed out in the way that John Allen was talking about. We really have to nail down these techniques if the data that's going to come out is going to be at all relevant and useful. Okay, so to conclude, the task of applying fracture mechanics to new and complex materials is challenging, and I think you probably knew that already. TC4, through its various working groups, is a we think, addressing these challenges, developing validated standardized approaches. And obviously what we're interested in doing is developing ISO standards. And I think one of the earlier slides demonstrated that we've had quite a bit of success in doing this so far. We do expect modeling to become more important to our activities in future. We have run one modeling round robin, which I haven't had time to talk about, but there's more of that to come, no doubt. If you'd like more information about TC4 and attending, for example, our next meeting, which notice it will be the full meeting, so that'll be the in-person meeting is going to happen in Dublin, in Ireland, hosted by Neil Murphy, so a member of ESIS TC4. The dates are there. If you're interested, do contact Laurent for more information. And we run a international conference every 3 years. So we've just had one. So our next one is actually on these dates in September 2027. So you would all be very welcome there. So I thank you for your attention. Thank you for staying. And if you do have any questions, I will attempt to answer. Thank you.